show that the maximum height and range of a projectile are u square sin square theta by 2g and u square sin 2 theta by g respectively, where the terms have the regular meanings. So in this question we are asked to derive the formulae for the maximum height and horizontal range of a projectile. So first we shall discuss the derivation for the formula for the maximum height. Imagine from the ground at point O, we are projecting a particle with velocity u, which makes an angle theta with the horizontal. The particle follows a parabolic path and reaches the ground. Imagine that the ground has x-axis and vertically upwards y-axis. Because velocity is a vector, we should resolve velocity into two components. They are ux equal to u cos theta along x-axis and uy is equal to u sin theta along y-axis. As the particle goes up, the vertical component of velocity decreases gradually. That means Vy decreases gradually and it becomes 0 at a point. So now the distance from that point to the ground is called as maximum height. So this is also defined as the greatest vertical distance traveled by a body before the vertical component of a velocity becomes 0. So now we shall derive the formula for the maximum height. For that, we shall use the equation v square minus u square is equal to 2as along y-axis. This becomes vy square minus uy square is equal to 2ay into s. So vy is 0, 0 square minus uy is u sin theta whole square is equal to ay is minus g and s is equal to h. So from this the formula for the h max becomes h is equal to u square sin square theta by 2g. So this is the derivation for the maximum height of a projectile. Next one is horizontal range. For the projectile projected with velocity u from point O with an angle theta with the horizontal, it follows a parabolic path and reaches the ground at point A. Now, the distance travelled by the body from ground to ground along horizontal is called as horizontal range. To derive this, we shall use the equation S is equal to ut plus half at square along x-axis. So we will get r is equal to ux into capital T, where capital T is the time of flight. Time of flight is the time taken by the projectile to reach the ground from the starting point, plus half ax t square. So because there is no force acting on the body along x-axis, acceleration along x-axis becomes 0 and time of flight is given by capital T is equal to 2u sin theta by g. So therefore the formula for range becomes r is equal to u cos theta into 2u sin theta by g plus 0. Now this becomes r is equal to u square 2u square sin theta cos theta by g. But we know that 2 sin theta cos theta is equal to sin 2 theta. Therefore, range becomes r is equal to u square into sin 2 theta by g. So this is the derivation for the horizontal range.